Hey class, Miss Anderson here. I'm going to start you out in Unit 9 here with geometric sequences. A geometric sequence is a sequence where each term changes at a constant multiple rate, like you're multiplying by the same number every time. And a sequence in general is a pattern of numbers. And then if you have a pattern of numbers that's changing at a constant rate, we call that constant rate the common ratio, and we use the letter R to notate that. So let's look at a couple patterns here of numbers and decide if this sequence is geometric or not. So we have this first pattern, which goes 4, -8, +16, -32. So you can see that it's clearly a pattern. We could predict the next number, and our goal is to decide how is it changing in between. So if we look from 4 to -8, we are timesing by -2, and then if we continue that here, timesing by -2, that works, and timesing by -2 again gives us our next term. And since we're multiplying by the same number to get the next term in the sequence, it is a geometric sequence. And our common ratio, notated by R, would be -2. Looking at the next one, I can tell right away that it is not geometric, even though it has a clear pattern, because it goes +3, +9, -27, and -81. And you can see when you're changing from positive to negative, that's because you're multiplying by a negative, and so it has to go positive, negative, etc. So this is a pattern. We're multiplying by 3 here, but we're multiplying by -3 here. So it'd still be considered a sequence, but it is not geometric because it's not the same multiple, the same common ratio every time. And then the last one, from 5 to 10, we're multiplying by 2, multiplying by 2 again, multiplying by 2 again. So this one would be a geometric, and the common ratio would be 2. And then the next one, it looks like we are going from positive, negative again, and we're getting smaller this time. There's a clear pattern. So getting smaller, we are multiplying by a fraction. Since 6 is half of 12, we are multiplying by -1/2. And then that holds true from this term to this term, -1/2. Half of 3 is 1.5, half of 1.5 is 0.75, and it's going back and forth between positive and negative. So this one would be geometric as well, and your common ratio would be -1/2. So if you can identify a common ratio as a geometric sequence, we can write a rule, which is essentially an equation that represents the terms in the sequence. And then you can use that rule to find any term in the sequence. And this is hopefully going to look familiar. It's going to be defined as a sub n equals a sub 1 times r to the n minus 1, where a sub 1 is the first term in the sequence, and r is your common ratio. And because geometric sequences are multiplying by something every time, they're getting exponentially large or growing exponentially or decaying exponentially. So they're going to represent similar to the a times b to the x, the exponential growth and decay functions that you've seen in the last unit. So a sub n represents our output of our function, or our y. A is our leading, our initial value, and that's our first term in a sequence. R is our base, or our common ratio, and the only real difference is instead of just to the x power, it's to the x minus 1 power, so that we start with the first term when we plug it in. So if I want to write a rule for this sequence, I need to identify my first terms. My first term is 2, and then I need to find my common ratio, which would be multiplying by -2. 2 times -2 gives you -4, times -2 gives you 8. So we can write a rule that would be like a sub n equals 2 times -2 to the n minus 1 power. And remember, that's going to be really similar to just doing 2y equals 2 times -2 to the x minus 1 power. Except for we're using a sub n. Typically, instead of y, you're used to seeing f of x. That's the same thing. So a sub n is just like f of x. It shows us that it's our output, and it shows us what our input is. So n is our input, a sub n is our output. So if I want to find a sub 10, that's like finding when x equals 10, what's your y value? Except for that it's n and a sub n. So when n equals 10, what's your output value? So to find the 10th term, you would just plug in 10 for your variable. And so that would give you 2 times negative 2 to the 9th power. Let's see if I can open my calculator here. And then make sure you type it in correctly so that you follow the correct order of operations. So if you type it in just like that, your calculator should give you the correct answer. So negative 1,024. So that means the 10th term is negative 1,024. So if you kept going here, you would find that the 10th term in the sequence is this value. That's what a sub 10 stands for in this situation. Or when you plug in 10, you get that output. Okay, so let's do it again. This time I have essentially an exponential decay function. My sequence is going down. It's very similar to the a times b to the x again, except for a sub 1, or a is going to be your first term. So in this case, it starts with the term 56. And then since we are decreasing, it's a decay function. We need to find what we're decreasing by. I know that 14 divided by 2 is 7, so our r is going to be a half, multiplying by a half there. So 56, half of 56 is 28, half of 28 is 14. So then you can write your rule for this equation. So you use a sub n represents your rule. It's your first term times your common ratio to the n minus 1 power. And then find a sub 7 means to find the 7th term in the sequence, or to plug in 7 for your n value. So a sub 7 would be the 7th term, be 56 times 1/2 to the 7 minus 1 power, or 56 to the 1/2 to the 6th power. So if you type this in all at once, it'll give you the correct answer. Otherwise, make sure you do the exponent term first, then multiply by 56. Because order of operations matters. And our last term would be 0.875, which is 7/8. Okay, so can we write a rule given some limited information? So we don't know maybe the first few terms of the sequence, but here we know the 4th term is 3, and we know that the common ratio is 7. Or I'm sorry, the 4th term is 3, and the common ratio is 3. So my goal here is to write this equation, a sub n equals a sub 1 times r to the n minus 1. And I don't know a sub 1, but I do know r. And those are the two things that we need to know in order to write the equation. So I know r equals 3, and then I know that the 4th term equals 3. When the 4th term equals 3, remember that's like n, a sub n is your input, output. 4 is your input, 3 is your output. So when I take 4 and 3 and plug it into this equation, along with r, I'm going to be able to solve for a sub 1. So a sub n is 3. Don't know what the first term is. I just know what the 4th term is. I know that r is 3. And then I know that n was 4. So I did n equals 4 there. And then I did a sub n equals 3 there. Now I'm going to solve this for a sub 1. So following my order of operations, we're going to do the exponent first. 4 minus 1 would be 3. Then 3 cubed is 27. So a sub 1 times 27. Then divide by 27 to find that a sub 1 would equal 3 over 27, which is 1/9. So now that I have the first term and I know the common ratio, I can write my final answer, which is the rule is the first term times the r to the n minus 1 power. All right, we're going to do one more, and this one hopefully is going to look similar to what we did in the last unit when we were given 2 points of a geometric, or 2 points of a exponential growth function, and then we're writing the equation for y equals a times b to the x, it's going to be very similar. So I'm giving you two terms of the geometric sequence. I'm giving you the second term, which is -4, which essentially means that you have the point 2, -4, where this is n, a sub n, instead of x and y. Those are our input-output values that we notate with sequences. And then the sixth term is -1024, means that you have the point 6, -1024, and again, that's going to be n, a sub n. And you're going to set up a system of equations. So we know that a sub n equals a sub 1 times r to the n minus 1. And we can do that on both sides here. And so for this one, we have -4 equals a sub 1 times r to the 2 minus 1. Be -4 equals a sub 1 times r to the first. Over here, it's going to be -1024 equals a sub 1 times r to the 6 minus 1, or -1024 equals a sub 1 times r to the 5th. Okay, similar process now. We have a system of equations with two variables. So our goal is to isolate one of the variables and substitute it in to solve. And so similar with the last unit where we picked the side that had the smaller b, it works out better if you pick the side with the smaller r. And we're going to solve for a again. And a sub 1 is just a subscript. That just means the first term. It's just a. It's not the same thing as a to the first power. But we're going to solve over here. We're going to isolate the first term. So we get a sub 1 is -4 over r to the first. Then we're going to take this value that we found for a sub 1 and we're going to put it into this side for a sub 1. We're going to get -1024 equals -4 over r to the first times r to the 5th. And similarly, since we have a fraction times a whole value, we're going to put that over 1 because we want to remember that this r to the 5th is being applied to the top of that fraction. So -1024 equals -4 r to the 5th over r to the first. Applying your exponent rules, r to the 5th over r to the first will reduce to r to the 4th. So -1024 equals -4 r to the 4th. Finish solving for r, divide by 4, -4. Is going to be r to the 4th equals 256. And then to get rid of the fourth exponent, we're going to need to take the fourth root. Now 256 is 16 squared. So we can do 16 and 16, and then we can do 4 and 4, and we can stop there because we have 4 4s, and that's what we need. So that means that the fourth root of 256 is 4. Now technically, we do get plus or minus here because it's two solutions when you take a real or take an even root. If I look back at my terms, though, I have a negative and a negative. So I'm wondering if I need my r to be negative or my r to be positive. I think it works out either way. You can either make the r negative and then your a would be positive, or if the r is positive, then your a is negative, and it will give you the right sequence. So I'm going to use the positive r value. So once I have that, I'm going to plug it back in over here so that -4 over 4 to the first equals a sub 1. So that means a sub 1 equals -1. So now I have a sub 1 and r, so I can plug it back into my rule, which is a sub 1 times r to the n minus 1. A sub n equals -1 times 4 to the n minus 1 power would be my final answer. Okay, for the sake of time, I'm going to stop the video here. If you want to see that example again, rewind and rewatch it. Thanks for watching.